Here we go, section 6.3, graphing to solve systems of linear inequalities. The goal today is to solve problems by modeling systems of linear inequalities. Mostly we're going to be graphing these, those are going to be the models. Now here's an explore question for you. Tomorrow, the beginning of class, you guys are going to present me some answers to this. It says, what conclusions can you make about the system of linear inequalities graphed below? So your task is going to be look at the lines, look at the shading, etc. And you're going to come up with some conclusions that you can make about that system. So I'll be asking you about that tomorrow. Let's move on to first example. Learn about the math. A company makes two types of boats on different assembly lines, aluminum fishing boats and fiberglass bow riders. When both assembly lines are running at full capacity, a maximum of 20 boats can be made in a day. The demand for fiberglass boats is greater than the demand for aluminum boats, so the company makes at least 5 more fiberglass boats than aluminum boats each day. When you guys go to solve these problems, there's going to be a series of steps that I want you to follow. Step 1 is going to be to describe the variables. So since we're talking about aluminum boats and fiberglass boats, I think we can say that A represents aluminum boats and F can represent fiberglass boats. So that's going to be step 1. I don't know if that's spelled right or not. Looks good to me. Step 1 is going to be describe the variables, which you've just done. So A is aluminum, F is fiberglass. Step 2 is going to be determine if there are any constraints on the variables. We're talking about boats here. We can't have a negative number of boats, nor can we have a fraction of boats. So what we're going to write in this case is that A is going to be an element of the whole number system because we need a whole number of aluminum boats, and F is an element of the whole number system because we need a whole number of fiberglass boats as well. So here's step 1, here's step 2. Step 3 is going to be where we come up with the inequalities. So we're going to go back to our information up here to determine it. So the first part says when both assembly lines are running at full capacity, a maximum of 20 boats can be made. Aluminum boats and fiberglass together are going to be a maximum of 20. So what we're going to say in that case is the aluminum boats plus the fiberglass boats have to be less than or equal to 20 boats. It's a maximum of 20. They can make 20, so equality is possible, but they can't make more than 20, so it's going to have to be less than that. The second thing says the demand for fiberglass boats is greater, so the company makes at least 5 more fiberglass boats. So there's more fiberglass, so we're going to add to the smaller number, which is aluminum. So the aluminum boats plus 5 is going to be less than or equal to the fiberglass boats. Again, we'll look at that. It says they make at least 5 more fiberglass boats than aluminum. So fiberglass boats is at least 5 more than the aluminum boats. So if we add 5 to the aluminum boats, this is still, the fiberglass boats is still going to be potentially greater, maybe equal as well. So there are our inequalities. Next thing we're going to do is graph them. So we've been working in 6.1 and 6.2 on how to graph these inequalities. So let's go ahead and do that. There's 2 different ways to do it. Now for this first inequality, A plus F is less than or equal to 20. The easiest thing to do to graph this, first of all, we'll set it equal to find our boundary. The easiest thing to do is to find the A and the F intercepts. Now, of course, to find the A intercept, we'll substitute F equals 0. To find the F intercept, we'll substitute A equals 0. When we do that, it's going to simply be that the A intercept is 20 and that the F intercept is 20. So that's going to make that one really easy to graph. If we look at the second one of A plus F is less than or A plus 5 is less than or equal to F, if we try to find the intercepts, it's not going to be a difficult thing to do. The problem with that is that the A intercept is going to be negative 5, and we're only talking about whole numbers here, so we're not going to want to do that. We're going to do something different. What if I turn the inequality around? Of course, I'm going to set it equal because we're trying to find the boundary. So instead of A plus 5 equals F, I'm going to write F equals A plus 5. Now this equation is already written in our y equals mx plus b form if we consider f to be our y variable. So in that case, what we could say is that our slope is 1 and that our y-intercept is 5 if we consider this to be y equals mx plus b. So our slope is 1, our y-intercept is 5. From the first inequality, we have an a-intercept of 20 and an f-intercept of 20. We have enough information now to graph these, so we're going to go ahead and do that. So for the first one, an a-intercept of 20 and an f-intercept of 20, we can go ahead and plot both those points. Here's the a-intercept of 20 down here, the f-intercept of 20 way up here. Now keep in mind that we're looking at whole numbers with the possibility of equality. So we need a green stippled line on the whole number points. So I'm going to do my best to get these to reach up here, meet up. Look at that. Lovely. So there's our line. Now the next thing we have to do is determine which side of that line we're going to be shading. So to do that, we can test a point. So a plus f is less than or equal to 20. That was the inequality that we just graphed. So we can test our origin, 0, 0. So that means a is 0, f is 0. Add those together, it should be less than or equal to 20. 0 is less than or equal to 20, which is of course a true statement, which means the origin is in the solution region. So we are to shade below that line. Now of course the shading, because we're talking about whole numbers with the possibility of equality, that shading is going to be done in orange. I don't have an orange marker, and it's going to be really dark, so I'm just going to leave it for now. We're just going to shade our solution region. So just keep in mind that this boundary that we have on the graph so far, that's going to be shaded below in orange. Now let's take a look at the other inequality to graph. Remember, we had a y-intercept of 5 and a slope of 1. So again, we'll take out our green marker, and we'll start at the y-intercept of 5, and we're going to use a slope of 1, which of course means I'm going to go up 1, over 1, or up any combination of that. If I wanted to, I could go up 5 and over 5 and get to this point right here and do it again, up 5 and over 5 to get there. I'll throw a few more points in between. Maybe I'll just fill it all the way in to make it look real nice. Keep it going as well. Now we have to figure out where we're going to shade in relation to that boundary point. So we'll do the same thing as we did earlier. We had the inequality a plus 5 is less than or equal to f. There we go. And again, we'll test that boundary, 0, 0. So we'll go 0 plus 5 should be less than or equal to 0. That gives us 5 is less than or equal to 0. That's not a true statement. So the area that we're going to shade in relation to the second boundary is going to be above, because 0, 0 wasn't in the solution set. So for the first boundary, we had to shade below. For the second, we had to shade above. So what we're going to see is that this region right in here has been shaded twice. Once for this line, once for this one. So we'll go ahead and we're going to shade that. So because this region was shaded twice, this is the solution region for this system of inequalities. Now don't forget, when you're shading these whole number points, you not only have to stipple your boundary, but you have to stipple inside that solution region as well with your green dots. Now ideally these green dots are just going on whole number points, which of course mine all just did. When you do this with your pencil crayons or your crayons or whatever the case might be, make sure you're shading everywhere. If I were to shade below and above the other two lines, what's going to end up happening is the shading is going to look about the same as what it is in the solution region. If you want to look in your book on page 310, you can see exactly how it should look with the light shading below the line, light shading above the other one, and because that one region was shaded twice, it's darker in there. So let's go back up and see what the question is asking us again. We have it graphed really nice. It says, what combinations of boats should the company make each day? So because this region here was shaded twice, any pair of numbers that we pick out of there, that's going to satisfy our inequality. So let's say we go to this point right about here. That's the point 3, 12. So let's try that. 3, 12. 3 on the A-axis, meaning 3 aluminum boats. 12 on the F-axis, meaning 12 fiberglass boats. So we're going to test to make sure that that point works. We're going to test both of the inequalities. So remember that the first one was A plus F has to be less than or equal to 20. So we'll go 3 for A, 12 for F has to be less than or equal to 20. 15 is less than or equal to 20 is what we get. True statement satisfies that inequality. Clearly, though, we have to check both to make sure. So the other one is a plus 5 should be less than or equal to f. So we will put in our 3 for a and our 12 for f. We will get 8 is less than or equal to 12. Once again, we get a true statement. So since we got a true statement in both inequalities, when we substituted the point 312, we can say that that point satisfies the inequality. Now, what we can also do with this to check, or whatever you want to do, we can take out our graphing calculators and we can use them and see what we get. So I'm going to go ahead and do that right now. If I can find it, here it is. So we'll turn it on. We're going to go back to y equals and clear this equation out of there. I'm going to have to change my window as I go along, but that's okay. So again, turn it on and press your y equals button. If there are any functions in there, get rid of them. So we're going to think back to our two inequalities. Now remember that one was a plus f is less than or equal to 20, while the other one was a plus 5 should be less than or equal to f. Remember now, when we go to graph these inequalities, we need to isolate y. That's the only way we can graph them on the graphing calculator. So like we did before, we're going to call a our x value and f our y value. So we'll rewrite them. Now in both cases, what we're going to want to do to be able to graph them is isolate y. So I'll do that with this first one right here. I'll go y. I'm going to have to subtract x from both sides. Y is going to be less than or equal to negative x plus 20. And with this one over here, all I have to do is flip this one around the other way. It's already isolated. So since x plus 5 is less than or equal to y, that means y is greater than or equal to x plus 5. So here are the two inequalities that I'm going to be able to graph. We'll go back to our graphing calculator. The first one, y equals negative x plus 20. So we'll go ahead and put negative x plus 20. But if I were to graph this, of course my window, I'm going to have to change that. Hold on one second. Try that. Much better. I don't have any shading, and the reason for that is because it still is an equals equation. So I'm going to go back here, turn these into our triangles, and we got to go lower because this is less than or equal to. So we want that triangle shaded dark below. So now I'll try graphing it again. Oh, that's nice. So we can see our shaded region nicely now. Okay, so we'll go back to y equals. We'll put the other one in. So this one we had y is greater than or equal to x plus 5. So I'm going to go over here right now, press enter twice it's going to be. So we have our triangle shaded upwards. So it was going to be x plus 5. So there's x plus 5. I'll graph that. And what we can see clearly is this region right here has been shaded twice. So that looks exactly like we did on the graph paper. So that is it for example 1 from section 6.3.